So we're very fortunate today to have our speaker, Dr. Bernard J. Baars. And so let me just read what we have on Dr. Baars here. He is a former senior fellow in theoretical neurobiology at the Neurosciences Institute in San Diego. Unfortunately, the NSI is no longer, but you may remember the NSI. He is really well known as the originator of what's called the global workspace theory, a concept of human cognitive architecture of the cortex and of consciousness. So Dr. Baars is considered really one of the founders of the modern science of consciousness. And his theory, this global workspace theory, provides an approximation, a model, if you will, of the understanding of how the cortex may produce consciousness. And as he will say in his talk, Wilder Penfield wrote that the cortex is the organ of mind, and so his global workspace theory is a model of cortex, if you will. And so he'll talk about that. And but in this talk, he's mainly going to speak about something called silent consciousness and suggest a way to study that. At the end of the talk, and I believe you're going to point out that he has these courses on consciousness. He has a recent book on consciousness that's in the back there if you want to take a look at it. But he's offering discounts for both the courses and the book. So if you're interested in that, he'll talk about that at the end, I think.
Sure.
And I'm available if you want to know the details. Okay. So welcome, Dr. Baars.
Great. Thank you very much. Hi, Jaime. And thank you everybody for being here. This is obviously the most important meeting taking place in San Diego today. And the other thought that occurs to me is that I should have joined this group in 1980, when I first had the privilege of working with some people at UCSD. And I managed to offend even the most open-minded people I knew by using the word consciousness. I need to show you this image. I should have this on a slide, but you can see that it's a timeline. It goes from 1950 to 2025, and it rises. It rises very consistently, and it is the frequency of mentioning the two words together of conscious and brain. This is from PubMed. You can bring it up by just typing in conscious brain, and it'll show this picture essentially. Around 1950, which was the height of behaviorism, also called denialism, because consciousness was insanely being denied, as you all know, in a way that seemed to be very plausible and that still had passionate followers until B.F. Skinner wrote his autobiography, which is kind of confessional, telling that he never stopped believing in consciousness. It was basically a fake out, and it's unclear empirically whether he was dissociated for a long time and simply could not use that language, or whether it was a publicity stunt. I think the gamble right now is about 50-50. I think he tells a very plausible story about why he became severely traumatized at the age of 20 or something like that, had what he calls his dark year, which was a highly traumatic year for him. His older brother died. His father lost his job as a lawyer for a coal company in Scranton, Pennsylvania, I guess it must have been. And B.F. Skinner, who was deeply interested in stream of consciousness literature and had dreamt of becoming a stream of consciousness novelist himself, gave up that dream. And altogether, that was so disturbing and traumatic that he became a behaviorist by reading Pavlov, who himself was very ambivalent about this. And at the end of his dark year, according to B.F. Skinner, he entered Harvard psychology department without ever taking a course in psychology. It's not clear that B.F. Skinner ever did take a course in psychology. And from day one, he tells the story, he was engaged in a vendetta, basically, with Edward G. Boring, was it Edwin or Edward, who was head of department at that time. And so he instantly got into debate with the most famous, especially the most famous historian and the most famous practitioner of Jamesian psychology, which was the dominant psychology before Watson took over. And Skinner became the heroic figure of American behaviorism and perhaps even worldwide behaviorism for the next, let's call it 25 years. It's actually a little bit longer than that. So there is this very curious history of behaviorism, which a recent philosopher calls denialism, the denial of the reality of consciousness in a common sense meaning of the word consciousness. The common sense meanings of a lot of psychological terms are really pretty good, and a lot of technical psychology consists of rediscovering common sense psychology, but this time doing it based on plausible evidence. So people in the field of personality have rediscovered basic personality traits. People in the field of emotion have discovered the whole range of emotions, not entirely completely, because emotions have a huge range that's deeply studied in the humanities. And what psychology has added, what academic psychology has added, I should say, is proof procedures and insistence on proof procedures. And that is an important development, I think. But in a certain sense, nothing new has been discovered. So, so a certain amount of modesty is very appropriate in this field, and that's especially true for consciousness, which is essentially at the center of every recorded culture that we know. And the reason that I'm not talking about the non-recorded cultures because we simply don't know. Although we know a great deal of anthropological studies, of course, of tribal societies who did not have a lasting way of keeping records. History, as you know, the word history means that which we have reliable records of, essentially. So prehistoric means, or used to mean at least, the things that occurred before the expansion of alphabetical languages, essentially. You can push things farther back in time, of course, in terms of written codes. They start much earlier, but it's useful to use the alphabetical systems of writing as a way of keeping records because we know more about them and because they are easy. Many earlier codes and later codes were restricted to a particular profession. So in Sumeria, for example, you had uh, you had specialists in writing. You would go to the specialist and they would write in whatever code they knew, and they were perfectly capable of expressing themselves in sophisticated ways that are not particularly different from what we talk about today, except of course today, compared to the last century, the 19th century, we are very ignorant and foolish because human knowledge sometimes advances and sometimes it collapses. I think we're probably in the middle of a collapse these days, particularly when it comes to psychological knowledge. You can take any of our famous writers and compare it to Henry James, for example, and there's no reason to believe that we are any better than Henry James was, or any of the other romantic novelists of the 19th century. So this is a strange field, psychology, because when psychology became professionalized, which was shortly after 1900, it declared most of human knowledge about human beings to be taboo and unscientific, which was a dreadful thing to do because it declared a taboo over the great richness that apparently all human families and tribes know about both about themselves and also about other human beings. Psychology is not something that was discovered in the mythical way that science is supposed to work. The same thing is actually true about physics and astronomy. And astronomers, as we are discovering more and more about free verbal astronomy, which goes way back, and we know that because of the accuracy of the alignment of monuments and so on, huge monuments very often. Astronomy started far long before professional astronomy started. Professional astronomy is often dated back to the discovery of planets as planets, although planets as wandering dots in the night sky, of course, was known for probably tens of thousands of years before that. But the solution to the problem that planets were Earth-like masses going in orbit around our local sun, that idea is attributable to what we call scientific astronomy. I get the impression that real astronomers, people who are paid to do that, and who consider themselves part of the guild of astronomers, and rightly so, they're quite uncomfortable with what has been called archaeoastronomy. And archaeoastronomy is every single hunter-gatherer who was able to walk at night and talk to his kids, because kids have to find their way back home to wherever the tribe, the nomadic tribe, is settling down for the night, so the kids can be safe. And the easiest way to do that is to teach the kids some very basic things about the night sky when there are no clouds, of course, to obscure the stars. And so very early on, you have to teach 3-year-olds or 4-year-olds who tend to run off in random directions very quickly, more quickly than adults can follow them. You have to have instructions of some kind to make sure that the kids don't get lost. And I think that's a kind of human universal. It's a very practical universal, but I tend to believe that a lot of human universals have a practical side for rather obvious reasons, because humanity until the last century perhaps was always walking a very fine line between extinction, pardon me, and survival. So human beings way back tens of thousands of years ago, we're really doing something called science if we describe science not in terms of some highly praised guild discipline, but rather in terms of the basic empirical things that every human being tends to do. So we study nature, we study each other. When we study each other, you could call it psychology or archaeoastrology if you want to bother with that. But you can pick that up, and anthropologists, of course, have studied tribal societies for at least 100 years. And one of the things that tribal societies do about each other, and gossip is a kind of psychology, and it's very often more accurate than official psychology. All this is somewhat relevant to independent scholars, which includes you all. And I keep on thinking that if I had known about this group 40 years ago, I would have joined it. Unfortunately, I did not know about it until Jaime got in touch with my director, producer, editor, and many other things, Natalie Keld, who also helped to set up this meeting, and I'm always grateful to her for doing a tremendous amount of work to keep things going. Our book called Unconsciousness is circulating somewhere, and I'd be happy to have you circulate it so everybody can at least touch it and cherish it. Or at least
Can
touch
I
it.
interrupt to say, I cannot.
Yes?
Hello?
We can't see the slides if you're advancing them.
Oh, okay.
And we've been putting that in the chat, but maybe the
See
chat isn't being
the
monitored.
speaker nor his screen. Perhaps one needs.
Okay, I'll have to do air drawing.
No, they can see the slides, we just haven't advanced them yet.
Oh, okay, fine.
We only see one
so-
slide.
That's all there's been.
That's all that we've shown.
Got it.
Right. I'm holding up a piece of paper.
Oh,
It shows a timeline, which reflects.
I cannot see you or the piece of paper on my screen.
Let me see if I can.
It doesn't matter much, I can describe it. It starts in 1950 and goes all the way to this year, January 2025. In 1950, the term conscious brain had virtually zero references in PubMed. Today, the number of references to conscious brain are above 30,000, maybe 33,000. And every time I look at PubMed to find out the latest figures, it's more. So suddenly, out of nowhere, we have a scientific field that could be called conscious brain science or consciousness science or something similar to that, but it's not such a good thing to grab a term, a single term for everything that's happening today. In my own life, I received a PhD in psychology way back when, and we were hotly discussing whether we were allowed to use the word consciousness. And I tended to think the answer was yes, which got me into all kinds of trouble, because what I didn't realize at the time was that the taboo against consciousness as a term wasn't just a local decision by psychologists who were skeptics, and skepticism is fine, but rather that it was required by the APA, the American Psychological Association, if you were going to accredit your psychology department and be respectable be a real scientific psychologist, you had to essentially hold on to a strict taboo against the term consciousness. You could try to find ways around it, but the trouble with that is that none of the synonyms for consciousness is quite the same thing as consciousness. The first great book in Western philosophy on consciousness is Aristotle's book, which can be translated on consciousness, or in the original Greek, I think it's something like peripsyche. And if somebody knows ancient Greek, do let me know if that's. But basically, Aristotle did not think that the psyche, what we call the psyche, called psyche, was a problematic thing. And as a great naturalist, Aristotle simply described the properties of the human mind, the senses, memory. I don't know if he talked about attention, but he certainly knew about attention. And he was interested, obviously, in voluntary control, which still has the fundamental legal meaning. There's a huge difference between accidentally hurting somebody and willfully hurting somebody. And in one case, you can be put away for life. And in the other case, you can be dismissed if you're nice to the judge. So volition has always been fundamental, as far as I can tell, in legal matters. Because after all, if somebody went around killing the wrong person, if you kill the right person, that is to say a tribal enemy, you were good. But if you kill the person who was a tribal hero, of course, you were the subject of revenge, an eye for an eye, tooth for a tooth, life for a life. So we've always, I assume, and that's a funny term, always, because we don't know always. What we know with very good archaeology these days, which has become tremendously sophisticated, both in physics, for example, we can pick up footsteps in the sand in the beaches of Morocco and actually trace human beings, hominids, walking a certain way. So we know that around some of the Great Lakes in Africa, where people naturally gravitated to, because around lakes you have fresh water, if you're lucky, and you also have fish and other animals come to drink, of course. So it's an ideal hunting ground. And of course, we were all hunter-foragers for most of our history, which these days our hominid history seems to be around 2 million years these days, and I can stand corrected on that if somebody knows better. And that's based, of course, on archaeology and a very careful examination of human remains. So we're quite an old species, and we're a very intelligent species. A current guess is that language may be 250,000 years old, but that's a total guess. I don't think anybody really knows. The oldest languages that we know are the Indo-European languages, Proto-Indo-European, and perhaps Proto-Semitic, and so on, other language families as well. Indo-European is the best investigated example of ancient languages, and it goes back fairly reliably to about 10,000 years. So talkative humans have been around in the Caucasus and elsewhere for 10,000 years. We're really quite an old species, and we're remarkably intelligent, even before we figured out how to use alphabetical scripts. So, did people know a long time ago that they were conscious? How about a vote? who would say that people probably knew 10,000 years ago that they themselves and their buddies were conscious? I think that's very likely. And now, of course, scientists have gotten to the point, and philosophers, that nobody knows who's conscious. And much of analytic philosophy, at least, is dedicated to making the question of consciousness more difficult to understand, rather than easier to understand. But the fact is that if you are standing or sitting in an upright position, you're probably conscious, you're probably awake. The reason is that when we fall asleep, we go like this, because our external muscles, our skeletal muscles go flaccid as soon as we fall asleep. We all know that probably from working late at night, bent over our computers, and suddenly watching our heads fall down, which is perfectly normal. It's a good sign that you should probably go to sleep. And I think just about every student at UCSD may have that experience. So this is not, in some sense, this is not difficult. Medical people have studied consciousness and unconsciousness at least since Hippocrates, 25 centuries ago. And Hippocrates wrote a book called On the Sacred Disease. And it's not because he believed that the epilepsies, which they had a lot of at that time, because people were constantly hitting each other on the head. So they had a lot of post-traumatic epilepsy, since they had a lot of fighting, and Socrates, for example, was a stonemason, and it's quite likely that people like stonemasons at that time simply carried heavy stones, and so they had accidents just the way we do. They probably did not have helmets, although I do not know that. I assume they were smart enough, basically, to avoid hitting themselves on the head and getting brain trauma and epilepsy. We know football players these days, of course, notoriously, and boxers, notoriously get head injuries, impact injuries, basically, that are difficult to diagnose because they mostly involve the breaking of axons that are submicroscopic. If by microscopic you mean a light microscope. So it was hard to identify this kind of widespread but very, very tiny damage until quite recently. And now, of course, we can see it, and we can diagnose it, and we can try to protect athletes who encounter head impact against those kinds of impacts. I don't think we're very good at it yet, but at least we're better than we used to be, and we're certainly more aware of that kind of very diffuse brain damage. That kind of brain damage also leads to epileptic attacks. So a lot of types of brain damage, even when they are treated properly over the long term, can lead to seizures. And that's still a problem. It was a problem with Phineas Gage, the famous railroad foreman who got hit by an explosive stamping iron that he was trying to well, he had gunpowder essentially in this hole in the roadway for a railroad that he was working on in New Hampshire, I think it was. And the common thing to do at that time was to use fairly unstable gunpowder, and you would tamp it down. And if you were not very careful, you'd get a spark from the iron, tamping iron, and of course the spark would set off the gunpowder, or it could, and you would essentially get a wound, in his case, that came from the left side underneath his cheekbone and went straight between the two hemispheres. And that's a very interesting case history. There's much to be said about it, but I'm not going to say anything. The only thing I'm going to say is that over the long term, even though he recovered quite well over a period, over the long term, he did develop seizures over a period of years, actually, and ultimately died from seizure disorder of some kind. The Hippocrates' book on the sacred disease was, in fact, a great rant by the school of Hippocrates against the notion that epilepsy was a sacred disease, because apparently a lot of people with seizures or who could fake seizures were making a lot of money at the time, 5th century BC, by faking seizures and then coming up with prophecies that would earn them a reasonable living. So that was an early example of quackery in medicine. And the school of Hippocrates did not approve of Hippocrates, pardon me. There's a Freudian slip for you. So on the sacred disease is actually an accusation of people who were quacks and who were faking seizures, or maybe they had real seizures. Remember, this is a time when head injuries were extremely common. People like Socrates went to war. Socrates was a foot soldier, and as a stonemason, he was extremely muscular. So he was a walking soldier. In some cases, he was protected by man's name I can't remember, but who was a cavalryman. And if you were on a horse, you were safer in general than if you were a walking soldier. In any case, Socrates may well have had injuries somewhere along the line going to war at a time when going to war basically meant hitting people on the head or getting hit on the head or both. And of course, there were job injuries, basically for people like stonemasons, like Socrates was. Socrates also talked about states of mind that could be interpreted as seizure-like states. The epilepsies are extremely rich source of odd and sometimes mystical experiences. And at a time when people lived very rough and simply took their injuries, and it was a point of pride to suffer your injuries and come back and say, I'm okay. And that time, of course, those kinds of injuries were common. There were all kinds of other medical problems that were common at that time that are fortunately not that common today. So the epilepsies may be one source of mystical experiences, historically speaking, because the kind of life that the ancient Greeks led, of course, was not that different from the kind of life that other hunter-forager populations led. By the time we know about the classical age of Greece, they actually had a city, of course, but the city was surrounded by farms, and the average person would work on the farm one way or another, which was not the safest job in the world either. So the epilepsies, or at least brain trauma, was probably a source of a great deal of information on unusual states of mind. That's a somewhat odd introduction to the question of pure consciousness or silent consciousness, which might be a better description, which I first learned about from Maharishi Mahesh Yogi in the 1970s when he had large lectures I went to one of them in LA, and of course, I thought the whole thing was nonsense. I couldn't believe that anybody could get away with talking such clear, obvious, self-contradictory nonsense. And with 5 years of practice, which I only did because my friends were doing the same thing, and they had a sense that something real was going on. I did not, had no sense whatsoever that this was other than BS. But after 5 years of practice, I started to think that maybe there was something to this. So I'm always balancing between skepticism and open-mindedness, which is what scientists do, just like farmers do it, and carpenters and the rest of humanity before we started to have computers doing all of our work for us. And the fact that we are alienated from the work of hard objects and muscular work really does change our world in many ways that are worth talking about. In some sense, I think your average peasant walking behind an ox with a plow was more in touch with certain aspects of reality than we tend to be today. And that should be a source of concern, because we actually know from Jonathan Haidt, one of our good psychologists, that young people who grow up with, let's say, with fascinating computational tricks of various kinds of this, which this is one. And just as I have to rely on the owl here to pick up my voice and maybe to take a look at the screen, I'm now distant from the reality of whatever this owl is picking up. We trust that our friends here have finally gotten it to work.
We hope so.
We hope so. And it'll always be a kind of miracle when it does work. Okay, so let me talk about silent consciousness. The idea of silent consciousness is nearly neglected in Western cultures, which is very strange, because it's all over Asian cultures. So in the Indian traditions, it's a core idea. In Chinese traditions, which are, of course, next door to India, in Southeast Asia, in Japan, and elsewhere, you have this seed of this idea that is referred to in somewhat different terms, but I think the term silent consciousness might be widely acceptable. I use it because I think it's descriptive. Or about as descriptive as I can get it. But if you read any of the celebrated sources in Indian traditions, the most famous one is an Upanishad, the shortest Upanishad that I believe exists. It's called the Mandukya Upanishad. Some of you may know about Mandukya honey, which you can buy in your store. And it's called, I assume, that because the thought of silent consciousness has this tremendous sense of beauty attached to it. And I don't quite understand how those fit together, because I'm a cognitive psychologist, and I normally ignore emotions if I can. That's not really true. There's a poem, a really extraordinary poem, that's at the end of a famous book, or books that used to be famous, edited by Reps and Shinzaki, that many of you probably know. It's called Zen Flesh, Zen Bones. And it's a translation with some commentary, I think. At the very end of it, is something totally different. That is sometimes called 112 ways of centering. And this includes mantra meditation. It includes mudras, like this kind of gesture that you see in statues, meditating statues. It includes staring at the blue sky. And in Western psychology, that is called the Ganzfeld. And people in Gestalt psychology in the 1930s were quite interested in the Ganzfeld because it seemed to be such a weird thing. The Ganzfeld is basically what you experience when you stare at a featureless blue sky. No clouds, no structures in your way. It is simply, it has no edges in the vocabulary that people use in vision. It only has this pure, undifferentiated visual field. The word Ganzfeld is not particularly good because what actually happens is what's called a blankout in the Ganzfeld, and the blankout is essentially, I believe, sudden consciousness. It's pure consciousness because you no longer perceive the blue sky as blue. And you can play all kinds of interesting psychological games with the Ganzfeld. One way to do it is to take a ping pong ball and slice it in half and put each half over one eye and simply look at some source of light. And the report is that it doesn't matter what you do, essentially. You can shine red light on it, or you can shine blue light on it, or just any light, white light, obviously. And you will have this experience of blank out. It's not even described pretty well, as far as I can tell, but I don't speak German very well. And a lot of this literature is in German because Gestalt psychologists were German speakers. Gestalt psychology is a tremendously important field, by the way. We rarely talk about it, but the hard-nosed scientists in fields like vision have essentially adopted all of Gestalt psychology to be real science, which is interesting because there's not a single conventional experiment in Gestalt psychology. Everything's a demonstration. If you think about the Necker cube, for example, or any of the visual illusions that people talk about, you don't need to do an experiment. You don't need to have a control group. All you have is this weird phenomenon that happens, and it just shows up every single time you look at the Necker cube or at any of the other Gestalt phenomena. So that's become part of science, just like so many other things have become part of science that don't quite fit the mold of our orthodoxies. And I rather like that because I think real science has to do with what you observe. And if you can observe with an experimental comparison condition, that's even better. But a lot of physics, for example, fundamental experiments in physics, like the double slit experiment, for example, nobody, as far as I know, nobody had to run an experiment on it because you get a single source of light going through two parallel slits, and you get this interaction, extraordinary interaction between the two slices of light, if you like. And that's all you need. All you need to overthrow all of the physics of optics before the 20th century. So really, science has to do with observation. And if you're a smart observer and you ask the right questions, and particularly you start to ask the difficult questions that seem to be paradoxical, and that's very often a key to your next insight. It's well known that Einstein didn't run experiments. He simply imagined writing on on the light wave in 1905, when he published it, and then in 1905, and that led to what we call the Einsteinian universe, because he simply thought through the logic, and it's not that other people had not imagined such a thing. It's just that he very rigorously thought through the logic and realized that there was a paradox, a very difficult paradox, and there's only one way, in his mind at least, to resolve that paradox. I think that silent consciousness is such a paradox, because for most of us, certainly for myself, when I first found out about what was called pure consciousness or silent consciousness, I didn't believe a word. And it took a long time for me to come to terms with it, because I had experiences that I could not explain. I still can't explain them, but maybe next year I'll have a hypothesis. And I actually mean that, because I think I finally figured out the way to ask the question in the proper way. But I could be totally wrong about that, of course. Silent consciousness still, the fact is that it has been observed many times, like the Gestalt psychologist observing the Ganzfeld. It was not described quite accurately, even by those guys and gals who were really good, really, they had the right mix of rigor and imagination. And of course, it turns out, of course, that we now are all Gestalt psychologists. We may not call ourselves that, but people in the field of vision have basically accepted all of the Gestalt psychology, except the theory, which was not a great theory. So this is a kind of opportunity, this paradox that we're dealing with, the fact that, let's say 2 billion people in Asia who were Buddhist or Hindus or Japanese Zen practitioners or any of those other people, they all believe in something like this. And they have different descriptions because people have different experiences. But I think that in Japanese art, for example, which is very tranquil and very quiet and very stylized, but it's not rigid, I think. I think it's artistic in the sense that if you build Japanese gardens, you're always learning something. So that's a progressive art form. And I think those people believe in something like silent consciousness, but we can ask them. So there's a way to find out. Okay, so I might as well get to the bottom line. I think there's actually a way to test the phenomenology, the experiential aspect of silent consciousness. And basically you do it in the same way. This has not been done, by the way, so anybody in this room is invited to do it. It's a very simple experiment. Silent consciousness is a moment in meditation, perhaps, where you no longer hear the sound of an air conditioner, because the air conditioner has conscious content, or hearing the air conditioner has conscious content. So what this predicts is that when you are going into this paradoxical state of silent consciousness, you should not be able to hear the air conditioner. And that leads to a possible experiment that we can all do, which is to have a source of sound of some kind, preferably white noise of some kind, because it's random, but it could be other things as well. It's very unclear. But one should be able to perceive gaps in the flow of sound. And you can be meditating at the same time. You could be doing all the fancy stuff. And you should hear gaps. The gaps are endogenous. Are coming from your brain. They're not exogenous. And the trick, I think, is to, for somebody who can control the owl here, or anything else that gives an auditory noise stream, all you need to do is put in some gaps, physical gaps, that are exogenous, and then see if your meditator, who gets both endogenous and exogenous gaps, presumably, if this hypothesis is correct, then the meditator should confuse the two kinds of gaps, the one that's real in the stimulus and the one that's endogenous and not in the stimulus. That's called confusability experiment. It's used in sensory perception studies quite commonly. That's how we know that different colors, for example, colors that are produced by lenses and colors that are produced by filters, that those are in fact the same, that the light frequencies are the same, they enter the eye, and they're completely confusable with each other. So if a computer has different kinds of color systems inside, either RGB or what is the other one?
Cyan and.
CMK.
Okay, let's call it CMK. Everybody will look it up, of course. So there are different mixtures of light waves, but they are perceived to be the same if you tune them properly. And they're confusable with each other. And that tells us about the conscious experience of the perceiver. So confusability has been used quite widely in the study of perception, and it's one way to get at conscious experience with really extraordinary amount of accuracy. I should say, by the way, that we have by now more than a century of really accurate studies of the sensory systems. They started with Fechner and others around 1800. They were rigorous, they were careful, they were self-correcting whenever people made a mistake, which was all the time, of course. And what they have given us today is essentially a cell phone, because everything about color in your cell phone and in your big screens and so on is based on a century of sensory psychophysics. And people claim very often, I think for some reason, it's especially physicists who are very good physicists, but they believe that nobody knows about consciousness. And I do not know why they believe that, except that possibly they think that's the last problem that physics has to solve. But no, parts of that problem have been solved, and it was solved by a physicist named Fechner and Helmholtz, and a tremendously important series of people who were doing science, even though they may not have been called scientists because nobody gave them tenure. Nevertheless, they were doing fabulous scientific experiments, which is most of the history of science anyway. I don't know if Newton ever got tenure. I sort of doubt it. But I simply do not know. He was certainly hired by, I think it was Cambridge, but I think as a mathematician mainly. And there's all kinds of people in the history of science who were not official scientists. Aristotle was one of them, but who were fabulous naturalistic observers, natural philosophers. And the notion of professionalized science is actually very recent. It goes back to roughly 1900, when everybody in America wanted to become a member of a profession. And psychology, for the first time perhaps in history, some historians should correct me on that, but perhaps for the first time in history, psychology became professionalized. which is to say that psychologists got money, they got positions as professors in academic departments, and they promptly invented behaviorism, which denied consciousness. And this is within the first few decades after William James wrote his Principles of Psychology, which defined psychology as the study of conscious experience. And William James's Principles of Psychology is still a landmark work, maybe the most inclusive work on psychology, on consciousness, that was published after Aristotle's Peripsyche, which was also on consciousness. The reason, by the way, why those books were on consciousness and not on unconsciousness is because nobody knew about unconsciousness. They realized there was something there. James wrote a famous chapter on habit, and habit has to do with learning a skill that starts as more conscious and becomes less conscious over time. So habit is a very natural way to study consciousness because you get before and after. And these days, of course, we know that the fMRI, the metabolic activity of the cortex, shows a huge amount of activity when you learn to play a computer game, and that when you become really skilled at it, most of that metabolic activity dies down and comes back to baseline. So we can tell if there's any philosophers walking around challenging the idea that the brain has anything to do with consciousness. We have some wonderful experiments showing that it takes work to produce consciousness. This metabolic work, there's a lot of metabolic work when there's something new going on, because the brain loves novelty, and the brain loves, let's say, attractiveness. The things that naturally, there's all kinds of things, of course, that humans are naturally attracted to, and those are very important. We don't pay enough attention to them, but it's a basic part of being a scientist, or being a child, or being a musician, or doing anything that requires creativity and curiosity. So consciousness is definitely dependent on the brain. Every once in a while, when I look at philosophy papers, which I rarely do because I always turn away from them feeling bad, and feeling disappointed that some philosopher has somehow figured out that consciousness has nothing to do with the brain. And they can only do that, of course, by ignoring the evidence. Consciousness does have something to do with the brain. And if you want to imagine things outside of the brain involving the conscious brain, you're certainly welcome to do that. There's no way for us to know everything, of course. We're on a pathway. We're learning more. The invention of brain instrumentation has been a tremendous help, but the brain instrumentation by itself is not good enough. You have to have some kind of comparison between a more conscious and a less conscious input. Automatization, habit formation gives you that because you're playing the computer game before and after, and in the after condition, you're much less conscious of exactly the same set of actions that you were doing before. So the field of consciousness science, I think, which goes back less than a century, it actually goes back more than a century, but it really has flourished. The 33,000 articles in PubMed that we have currently under the search term conscious brain, most of those have emerged in the last 50 years, roughly, which is nice because now it gives us something to think about and something to work with, and maybe something to test. And that makes us much more confident, of course, that we're talking about the real thing. I should also mention, as long as I'm talking about conscious perception, for example, which is what we mostly study in the careful empirical study of consciousness. But of course, we have states of consciousness as well. We have waking and sleeping, for one thing. And the greatest discovery, perhaps, in that field was by a French scientist named Pierre Jouvet, in 1924, thereabouts, I think it was, who discovered that dreams are conscious. But apparently, he did not allow himself to say dreams are conscious, as they obviously are, because we have memories that we can remember from the dreams. We can play games with lucid dreaming, for example, and people can remember lucid dreams. They can even learn a task. The one that I know about is one that was done in Dement's sleep laboratory at Stanford, maybe 30 years ago, where the instruction to the subject was when you hear a click, which you can during sleep, you should move your eyes back and forth like this, count to 10, and then do your back and forth and back and forth. It's really easy to pick up the eye movements because the eyes are essentially batteries. They're very powerful batteries. They have they have polarity. And so if you put an electrode on the side and another one at your earlobe, you can really pick up these huge eye movements. And Jouvet is mainly remembered for talking about what he called paradoxical sleep. Paradoxical sleep was the wrong term, I think. And I once had a chance to meet him, but I didn't ask him the logical question that I should have asked him, namely, why do you think this is sleep? People are not unconscious during dreams. And I think it was because he was quite a conservative person, which good scientists very often are. And the idea of talking about conscious dreams may have been too provocative at that time. That false claim has now entered all the textbooks that we all learn about Jouvet having discovered paradoxical sleep, which is a misnomer because the real thing that's going on is conscious dreams. Dreams are conscious. And there's a variety of sources of evidence for that, but the simplest is EEG. And the best one actually is intracranial EEG, where you don't have to worry about this very thick skull that people have that gets in the way of brain signals. But you can do it with regular EEG of the kind that people use in medicine. And basically what you get is something that looks like fast white noise, essentially. The trouble with, and people in emergency rooms, when somebody comes in with a head wound, they always use the medical EEG, which is still scalp EEG. The trouble with that is that there's so much reduction in signal strength between the cortex and the outside of the scalp that most of what you're picking up is just noise from unknown sources, essentially. But you can do the same experiment, of course, with intracranial electrodes, and the great discoverer on that was Walter Penfield, who started to exploratory experiments in epileptic patients who, at that time, you had to find the location of the seizure. And very often you can find seizure sources, but the way they had to do it was to open the skull in a obviously very clean way, and stimulate the skull with an electrode. The whole thing was fairly crude at that time, but it was very safe. And that's by the time Penfield got done, they had studied 1,200 epileptic patients. And whenever they stimulated certain parts of the cortex, they would get the waking subject saying, "Doctor, I feel a touch on my hand." Or, let's see, yes, I see a fuzzy light, because you have to get the right signal in order to stimulate it properly. Of course, Penfield didn't know what the right signal was. He simply used some source of electricity, low-level electricity, to be able to make sure it was harmless. But he was able to show over 1,200 cases that cortex is indeed the organ of mind, as he used that term. And he certainly meant the conscious mind, because his patients were talking to him. So he made major discoveries that were published later on. And the only trouble with his work is that as an ethical neurosurgeon, he refused to publish the names of his subjects. So we know only one person, I think, maybe not even one person, from the 1,200 patients that Penfield and his team at the Montreal Neurological Institute studied over a 30-year period. We get lots and lots of information, but we don't know anything really based on more recent evidence about the particular patients. But I think that was a great discovery. I think it was a solid discovery. There was no reason to doubt it, because he kept on doing it with more and more and more patients. And then, of course, other neurosurgeons also picked it up. The reason why this scalp has to be opened up at that time is because people did not have a map of cortex, and cortex is a very adaptable organ, so that if you have an injury of some kind, if you have epileptic seizures that may emerge in the temporal lobe especially, that's the classical locus for epileptic seizures, then you've changed the cortex by the time you test it. So you can't generalize from one patient to all patients. But by this time, of course, we have all kinds of wonderful instrumentation that do not require surgery and that are perfectly safe. And we now have extremely detailed maps of the brain, and especially the cortex, and what Penfield wrote in 1924, namely that cortex is the organ of mind. That turns out to be true, which is another good argument to talk to your philosophical friends who may believe that consciousness has nothing to do with the brain because they don't look at evidence, neither medical evidence nor more modern evidence. What we have right now, of course, is something that came out of that very long series of studies in animals and in patients of various kinds, and later on, of course, with much better equipment that was not invasive, so did not involve surgery. We now have the ability basically to observe the brain directly. But still, I think the gold standard for cortical observations is still the intracortical study. And you can do that, and people find amazing things because, of course, the scalp, we are very thick. We are very thick-headed creatures. And there's a good reason for that, other than stubbornness and so on. There's a good reason for that, because of all the hominids, or rather of all the it's not all the hominids, it's really all the ape-like creatures that we know. we are dumb enough to carry our heads straight on top of our bodies where anybody with a block can hit us. And that's very interesting because evolution does not make those kinds of mistakes unless there are compensatory features. And I think the fact, of course, is that if you hear a nearby explosion, the first thing you do is duck like this and use your shoulders to protect your head. That's a very good idea. And that may be a behavioral protection against head injuries. The history of war, which is pretty much all of history, consists of people trying to hit the heads of other people. And they people know how to do that. This is hunting lore that every hunter, probably in human history, has known, because it's the same method that we use to hunt animals. We try to hit them over the head if we can, and if we can't, we bring them down in some other horrible way. Actually, hitting the head may be the most merciful way to hunt animals and people. Okay, so we have extraordinarily thick skulls. So there's a reason why your relatives will never agree with you. It's just the way we're built. But now, of course, we have the privilege of being able to see inside of the skull, and the skull has, and the cortex particularly has been mapped out very beautifully, so that now we're talking about something called the connectome. The connectome is basically the connectivity map of the cortex, which is very beautiful, and it was worked out at the cellular level maybe 10 years ago. So if you're interested in cortex and consciousness and so on, the connectome is something you might want to look up. It's extraordinarily symmetrical, or at least it looks that way in terms of the main highways. Of course, there are tiny neurons throughout the body that you cannot see even with a good light microscope. You need something fancier than that. And physicists, I've said critical things about physicists because they think that consciousness is a problem in physics, which it is not. But physicists have provided this extraordinary armamentarium of brain imaging, and they should get all the credit in the world for doing that. One of the things that we started to learn about meditation, actually, let me bring this back to meditation. Some of the early studies showed that alpha waves seem to be bigger and more forward in the brain. So that there was a change in alpha waves. And of course, we've known since the discovery of alpha waves by Hans Berger that alpha waves in the occipital cortex has something to do with consciousness. And the reason is that you get alpha when you close your eyes. So somehow you cover your eyes, or you close your eyes, or you look into a Ganzfeld, and what you get is alpha blocking, typically. Actually, I'm not sure about the Ganzfeld, but I do know about a normal visual field that's very rich in detail and what are called edges, which are basically transitions in the brightness of parts of the field, as you are seeing right now. So we knew from Hans Berger's work on his son, who was the first subject to show EEG, and the reason was that Berger had the best electrical amplifiers in the world, because Siemens electronics or electrical industry gave him the high-powered amplifier, which was an analog amplifier, of course, at the time. And so he was able to do the first EEG. And one of the things he found, remarkably enough, is when his son was kind of looking at a distance, not particularly focused, he would see this beautiful little sine wave over the occipital cortex, which should have raised all kinds of questions, because the world is full of oscillations, but the world is not full of little sine waves that look so cute and pretty and have the same amplitude and the same distance between peaks and between valleys. So, so this should have made people mad with curiosity, and of course, in a sense, it did. But I don't think we really understand, even at this point, what causes alpha waves. We know that there are many sources in cortex that cause alpha waves or alpha-like waves that are pretty much in the 8 to 12 hertz range. And we also know that other species of mammals certainly also show alpha waves, maybe a little bit slightly different frequency range, but basically the same. For some unknown reason right now, the medical people have decided that we're going to call alpha waves theta waves. And this is ridiculous because traditionally, of course, what you do is you call waveforms or colors or anything new that are discovered, you call it alpha, beta, gamma, delta, because the only thing it does is reflect the order of discovery. And Hans Berger discovered the first regular waveform in the brain, and so he called it alpha. There's no better reason for calling it that. But early on, the slightly slower range was called theta, presumably because it was alpha, beta, delta, what is it, 5? Presumably because it was the fifth one to be discovered. Am I very wrong? And theta waves have turned out to be exceptionally important. Alpha waves are important enough. And there's continues to be debate because it can be found in many locations in the cortex. And it's very likely that the different locations of alpha are essentially dancing with each other. They go into synchrony because they have the same oscillatory properties. So they tend to sync together, just like waves in water or waves in air for that matter. They tend to sync together, so it's likely, I'm not sure about this because I have to look up the latest and greatest. It's likely that these different sources of alpha waves indicate both local and global activity. Local when there's a single source, and global when all these sources are starting to dance in sync with each other. Theta waves are now known to be a key to learning. And that's important. And theta waves, they have a number of functions, particularly with regard to the hippocampus and the relationship between the hippocampus and the neocortex. When you learn something new, you initially encoded in hippocampus, and then the next time you fall into deep sleep, the hippocampus takes that information and broadcasts it to the rest of neocortex. That's very important because you can do organizational work, let's say, to take the kind of random input that you're taking in every single second right now when you're awake, and it has to be organized in later brain activity. Excuse me. The hippocampus does part of that. The hippocampus is actually paleocortex, so it's a very old cortex, which means that it has an evolutionary history that's pretty fundamental. And the hippocampus basically uses theta waves during slow wave sleep to broadcast information to the rest of the neocortex, where the real memory traces are kept. So medical people have been very interested in this because people who have difficulty with memory, for example, may well have problems with that whole complex of anatomy and physiology, the hippocampus, the theta waves that blast out the signal from the hippocampus based on conscious learning, I should say, during the waking state. And now it turns out that you can stimulate theta wave oscillations from the outside. And there's about a half a dozen ways of doing it. I once took about 6 weeks of transcranial magnetic stimulation. I was interested in it, and I thought I was feeling depressed, and this was supposed to be an answer. It is FDA approved for moderate depression. Probably won't do much for mild depression, but now, of course, being stimulated by that discovery and by the fact that the FDA has approved it as a treatment for depression, there's now all kinds of motivation, including economic motivation, to pursue this theta oscillation, this externally stimulated theta oscillation. It's magnetic stimulation, so you don't have to do any surgery at all. And typically, the electromagnetic coil is placed over the left forebrain. I'm not entirely sure why, because you could do it in many different places. And of course, these days, you can even go beyond electromagnetic stimulation. You can do it with ultrasound. You can do it with DC electrical signals and so on. So it turns out if you stimulate cortex even through the scalp, and you get enough activity in the underlying neurons, which are typically on the outside of cortex, of course, you can get very interesting results. And this turns out to be a new modality that looks like it has medical applications. So there's a small industry going on right now, trying to figure out how you can use stimulated theta. And this really makes, this is really based on discoveries going back all the way to Penfield and even before, because Penfield discovered that directly measured electrical activity in the cortex when you take a little flap of the scalp away and make sure it has a continued blood supply, of course, so that you do no harm. And then you can stimulate with electrical stimulation or anything else for that matter, different part of the cortex. And you've seen the pictures of the cortex, I'm sure, these days that show it's essentially a megalopolis. I've reluctantly adopted that word because it's about right. The cortex is the enormous city of localized, specialized activity. The best known ones are in the visual cortex back here, but we're finding all kinds of things that are called circuits in the brain, including very close to the hippocampus itself. And so now we have this megalopolis, but we also have global activity in this megalopolis, which makes me happy because I've talked about the global workspace theory, which is an idea that initially came from AI and computer science, where they found that what they called a global workspace architecture was very, very good at speech perception at a time when speech perception was nearly impossible to do. We're still using similar methods today. Even Apple is using something like a global workspace. So the important point, I suppose, right now is that you have local activity where single neurons can do specific tasks, and you can even get voluntary control over single neurons in the temporal lobe, by giving conscious feedback as soon as the neuron fires. So you take the neuron, the electrical activity, has a spike, you play it through amplifiers and loudspeakers, so you get a conscious event. As soon as the neuron fires, and lo and behold, you can get voluntary control over that neuron, which I think is actually something that must have something to do with consciousness, but nobody believes it, so I'll just have to say it more times. Anyway, consciousness turns out to be extraordinarily interesting, and of course, extraordinarily functional, biologically speaking. It is not some epiphenomenon, as has been argued, and there are people who still believe in the in consciousness being an epiphenomenon. They're all wrong, of course, because they're not paying attention to the evidence. And that's one of the interesting things about consciousness is that it drives people crazy. It's like sex.
Bernie, sorry to interrupt, but we really are running out of time, so.
I just
kick
want
us
the
out.
sex.
We have it up till 3:00.
Thank you.
So,
Thank you very much. So the last thought I would like to leave with you is that consciousness is just like sex. Nobody ever agrees with anybody else. And even though those 33,000 articles are now in PubMed, and you could just read all of them, they're not that difficult. But the whole profession of academic philosophy, as far as I can tell, rests upon not reading that literature, which is unfortunate. I happen to like it, but you know, I don't blame them, not very much. I do think, by the way, that the whole study of consciousness is very humanizing. It's been considered that for all of Western history, and as far as I can tell, all of Asian history also. So I think it's regrettable that what Strawson, the philosopher, called denialism. Denialism is still very common, even among very good scholars. So I'm the original anti-denialist, I suppose. But so was Aristotle and Plato and Panini and all the gang. That's my story.
Stick to it.
yeah, I think we have time for questions. Hopefully they won't pick us out.
Have you ever done any work that considered the glucose in the brain and whether or not diabetes affects the consciousness and how the brain responds to a lack of the proper amount of sugar to generate the signal?
Well, it's a good point. The brain runs on glucose, as you know. And I'm sure that there are cases of low glucose that lead to fainting and even death if it gets low enough. So unquestionably, an important part of the story. Some of the brain imaging methods are based on glucose detection. And by and large, the metabolism of the brain, you can find hotspots in the brain, so-called, which are places where there's a lot of neural activity, and neurons use glucose, of course, and oxygen in order to function. So yeah, there's a very tight relationship. And there's also, I think there's also the case that outside of hypoglycemia, there's considerable independence, autonomy of the brain from foods that you eat. The exception, of course, is a genuine hypoglycemia when you essentially you lose consciousness, is the right way to talk about it. And that's because consciousness requires energy.
Two super quick questions, they're both valid. First is, what's the latest research on the thalamocortical loop being the center of consciousness?
Yeah, it's really the thalamocortical system is the organ of consciousness, essentially. And it's a little misleading because if you look at the gross anatomy of the thalamus and the cortex, they seem separate. The thalamus looks like a bird's egg in a bird's nest. But it turns out that it functions as a single organ. So you get resonance between excitatory neurons, one in cortex, one in thalamus. We have about 86 billion neurons, and as a wild guess, I would think that that cortex has more than half of that, and that thalamus has less than half of that. But I simply do not know that to be true. I think that's a reasonable guess.
And the second quick question is, as we now know from fMRI testing, most mammals and at least two bird species, the pigeon and crow, have either a full cerebral cortex, or in the case of the birds, a cerebral cortex structure. I already thought this through, but I'm curious from a neuroscience.
Say the last thing again.
Okay, as we now know, most mammals have a cerebral cortex, and at least two bird species, being the pigeon and crow, have a cerebral cortex structure. This is obvious, as you know, recently known from fMRI testing. I already thought this through, but I'm really curious from a neuroscientist perspective, what does this mean to neuroscience?
Well, the plausible inference is that birds are conscious. Right? And that basically any creature that has either the thalamocortical system or a close analog of the thalamocortical system should be considered to be conscious. And about 5-10 years ago, a group of comparative biologists who were very interested in this proposed that birds and reptiles were initially said to have a pallium, structure called a pallium, which is basically cortex. And 5 years ago, whenever it was, they published an article, a lot of very distinguished people saying we should drop the word pallium for birds and reptiles, and we should use the word cortex. So, so the real scientists agree with you on that, because those people really study these things in tremendous detail, including the evolution and so on. This was very disturbing to me because I didn't think it was true. And then I thought about it and I realized it had to be true. So, so I think the experts, the comparative biologists who study brains in different species, I think there's good consensus among the real scientists, meaning the people who look at evidence, that a tremendous number of species out there that we were skeptical about in terms of consciousness, but they really are conscious. The weirdest example that I know is cephalopods, because cephalopods have brains that are wrapped around their throats. They don't have spinal cord, and so they don't have a brain stem in the sense that we talk about it in mammals. But cephalopods, I have a friend who studies cephalopod intelligence, and he's pretty sure but that's based on behavioral phenomena. It's difficult to study the cephalopod brain because in water it's hard to study, and then of course they're very mobile, and so the fact that it's hard to study should not stop us. Obviously, we should just study those organisms.
I think we have a couple more questions here. Yeah, one, I see 3 hands up, so. Lisa's hand is up first, I saw yours
So mine
second
is
or
kind
third.
of tied in, so I watched the podcast of yours and you were talking about the sensory information, like the five senses, which you said there were.
I'm,
more than
I'm, I'm
that.
sorry, you're speaking very softly.
You said there's five sensory information coming in, and you said that there's five senses, but you said there were more than that, and then you talked about, and with respect, I think, to silent consciousness, the role of the insula
Yeah,
and feelings and internal states.
right. Yeah, that's all
And
true.
intuition.
Intuition is a very interesting case because that's also the technical term is feeling of knowing. And there are all kinds of feelings of knowing that we have, of course, and they could be the basis of silent consciousness. It's possible, and certainly people who are adept in meditation techniques, I think they would argue that intuitions and feelings of knowing are in fact states of silent consciousness. It's just that we don't perceive them with the clarity that we sometimes perceive silent consciousness during meditation or similar techniques. One of the things we have to do, of course, in this game is to learn to experience something that we think may not be an experience when we learn more about this. And musicians and artists know this, of course, that if you listen carefully to music, and the fifth time you listen to it, it'll be a different experience than the first time. So experiential learning is a really, really important thing. We don't talk about it nearly enough. It's somewhat hard to study, but it can be done. You know, all you need to do is figure out some kind of experimental technique to do it, and that should be easy. Musicians who are used to talking to other musicians do this all the time, right? You just point to a certain note or a certain interval before a certain note is studied. Intervals are very important, as you know. Delays are very important. And they can talk to each other and they have a shared vocabulary. But outsiders very often don't share the vocabulary. They haven't gone through the 5 years of playing the fiddle or whatever it is. And so it's hard for outsiders sometimes to pick up the subtleties.
I think Paul has a question.
You know, I wondered in your sense about how the subcortical neural processes feed into consciousness, and particularly in terms of pre-conscious knowing.
It's an interesting point.
And also the vagal nerve is that whole system.
Yeah, the autonomic nervous system, the cranial nerves, the vagus is particularly interesting because I think there's probably a subjective aspect to vagal nerve stimulation, depending, you know, it goes all over the place, right? So it probably depends where you stimulate and how you stimulate the vagus nerve. It's very interesting. The autonomic nervous system is called autonomic because it was considered that we are not in voluntary control of the autonomic nervous system. Whereas the central nervous system, of course, we have considerable voluntary control, although not 100%. But one of the things that marks the cortex is the volitional system, the voluntary control system, which involves prefrontal cortex, and which is also very, very interesting in ways that we can talk about another time. In any case, the medical orthodoxy for a long time was that the autonomic nervous system does not enter consciousness. I think that's wrong. And somebody, I think, mentioned the insula. Oh, good. And the insular cortex is very, very interesting because I believe that activating it does turn into internal feelings that probably involve smooth musculature rather than striped musculature, the outer inner, the gut feelings basically probably involve smooth musculature. I think that is still insufficiently understood, but I could be wrong about it because it's a big world out there. And, 33,000 articles just on consciousness. I think we might have missed something or two.
This may have nothing to do with this particular topic of silent consciousness, but there was an article or an opinion piece by a physician in the New York Times this morning that talked about people with traumatic brain injury or in comas. And have you ever tested any of this on those people? Because her premise was that there was more going on in the brains of people who were unresponsive than perhaps we realize.
Yeah, I think that's been verified by Stephen Lauries and other people who have worked on comatose states. And it's certainly true that subtler forms of unconsciousness were ignored by medical people for a long time. If you didn't get, if your comatose subject did not respond to their own name, for example, or to the classical thing in medicine is the blue thumb syndrome, because every MD who walked by, including students, would press the thumb of the comatose subject, and if the subject didn't respond, then they were in coma, and very often they were simply shipped off. Fortunately, we've gotten much better with that. Stephen Lauries in Belgium is one of the people who has worked for some decades on that, and we're getting better with that. But it's entirely possible, of course, that we still miss cases of what is sometimes called minimal consciousness, some kind of and I think people are looking for minimal consciousness because there's a school of thought right now that seems to indicate that simply parts of cortex can show activity that we would consider to be conscious. What we thought of as simple states, sleeping, waking, dreaming, are anything but simple. For me, the most interesting thing, of course, is the consciousness of dreams, which, informally, if you pay attention to your dreams, you'll probably, when you wake up and make little notes, you'll probably realize that you actually had vivid visual senses, for example, and maybe vivid movements, vivid emotional experiences, all those good things. And it took a century of hard science. That's not quite true. I'm being pessimistic about that. Jouvet in the 1920s, I think, called it paradoxical sleep. And this is a mistake that's still being made by famous neuroscientists, I could name, but I won't, who interpret behavioral sleep as unconsciousness, when they know perfectly well that you could be lying down, perfectly conscious, and all you need to do is not move a muscle. And you look like you're in coma for all intents and purposes.
But that could have profound effects for what kind of conversations between physicians, nurses, and others should go on.
Yeah.
Someone who appears to be comatose or unconscious.
Exactly right. So you have to be careful. Or you can use it, right? Because you can pick up some EEG activity, evoked activity, when you use a person's name, for example. And I think that's become routine medical practice. But really anything, any stimulus, especially something that's emotionally personal, is likely to trigger cortical activity. And that may mean general unconsciousness.
In terms of your statement about dreams, I think you published a paper in 2013 in which you proposed another way to detect silent consciousness. And that was that you would look for, that would be a period of time where there were only either delta or theta waves, I believe, with no gamma spikes on top of it. And in that light, I'm wondering what you think about slow wave sleep. I believe that there is some ideation now detected on top of slow wave sleep, but as to a large extent, it's delta waves or very slow waves.
Yeah, good point. I do not know the answer because I have to look at the latest and greatest. The thing with delta waves, of course, is they're very large compared to other waveforms. And because we're looking at complex waveforms, not sine waves, we don't know the composition of the complex waveforms until we do a Fourier analysis or something similar. So it's entirely possible that waking activity could be going on at a very low amplitude, and it's being masked by the big waves. And that's why I have to look up the latest and greatest.
The reason I was thinking about that is that some meditators claim that they need less sleep. And so then the question was if meditation and deep wave sleep have some similarities. And that was what I was asking.
Yeah, it's a very interesting question. And for my next great experiment, which I don't have, because I don't have a laboratory, but anybody here with a laboratory should do this very definitely. The one hypothesis about silent consciousness is that we have what are essentially carrier waves in the brain. So alpha and theta, theta is particularly good candidate for carrier waves because we know it broadcasts recent memories to the rest of the cortex. So it somehow has to carry content. And this is a problem that there must be some evidence on when I think about it. So I need to take a look at PubMed and see what people have done in that respect, because people who study hippocampus probably have ideas about that. Certainly what you would get, I think, is if you have a conscious visual experience during the day, and then you go to sleep and you go into deep sleep. One possibility for hippocampus rehearsal is for the hippocampus to trigger off your visual cortex, which would then broadcast a reminder, essentially. Because we do know that spontaneous reminders do occur in the brain. So that's another thing to look up.
What is a spontaneous, what did you call it, a spontaneous reminder?
I think that's a reasonable terminology. You'd have to see what the sleep people call it these days, because the exact language of what they use to refer to what I'm calling reminders, you need to find out the exact languages. It's not difficult. And then that would lead you into the actual literature on that. And I'm sure that somebody has wondered about that. Sleep people are very good, many of them. So they do think clearly. And they do discover all kinds of things that we never realized before.
I'm sorry.
Sorry. Yeah. I've heard in connection with that very coded question about non-mammals, which have cortical activity or structure or system, and those which have just a structure, synonymous structure. You said they had consciousness, you bet, I guess is what it would amount to, paraphrase, that they have consciousness. What do you mean by consciousness there? Consciousness there, that they have global workspace, that they might have metacognition, that they are conscious? What exactly would you say mean by consciousness in that context?
Yeah, I really prefer to be as operational as possible, to stick as close to the known evidence as possible. And so global workspace theory is a theory, and I
Okay.
keep on looking for evidence, and actually I keep on finding evidence, which I'm astonished by. But how do we define consciousness
Well, what do you
operationally?
mean by consciousness in that context of your response to that question, that basically you bet that they're conscious, that they're conscious?
In science, I think one is much more comfortable with operational definitions than with theoretical definitions. And that's particularly true when you're dealing with early theory and you don't really trust the theory very much. So then you always go back to the observables, and different people may have different labels for the observables. But with regard to consciousness, we have at least a dozen observables, including this very fast low amplitude activity, which is messed up with the scalp EEG. But if we look at intracranial EEG, we just get wonderful signal to noise ratio. So we can certainly tell when the cortex is conscious. There's any number of other things that can be used. The ability to exercise voluntary control is one of them. The traditional one, going back to the early psychophysicists, is being able to signal a sensory event. Somebody mentioned, are there only 5 conscious senses? And the answer is, of course, no. We have 5 conventional senses from Aristotle, who's not a fool, but we have pain perception. We have in rodents, we have what's called the barrel cortex perception, which connects with the vibrissae, the nose hairs of the rodents, which are extremely sensitive, and they do emerge in consciousness in some way. Somebody mentioned the internal sensory systems, the ones that seem to involve I'm blocking on the word. You mentioned that.
She's outside.
Sorry?
Vagus or proprioception? Proprioception?
It is proprioception, but there's a particular piece of cortex that's involved with
Oh,
The insula.
insula. Thank you. I need people around me all the time, because otherwise this goes. By the way, the tip of the tongue state is mentioned in the great poem that's at the end of the book by Shinzaki, and the book called Zen Flesh, Zen Bones, which is a book I highly recommend if you can find it in the used bookstore. It should really be republished because it is a wonderful source of information. And at the very end of it, it has this great poem. It's a Kashmiri poem, essentially, which is a duet between a god and a goddess who tell each other about these 112 ways to have transcendent experiences, and they celebrate every time they mention another one. They celebrate the deliciousness of that transcendent experience, which I don't have that much of, and I'm looking forward to getting some of it as soon as possible.
I gather from your answer that you gave to my question that you're saying that what you meant by consciousness there is that they do experience, as opposed to just being automatons that do not have experience qualia or, phenomena in the subjective phenomenon sense, that they are actually perceiving these things as opposed to being robotic. That'd be fair to say?
Yeah, I think qualia is a philosophical term, and I don't trust it. Because the philosophers really don't pay much
Okay, then let's move
attention.
to phenomenon, but you know what, I know, I used it because you used it, that in a writing, but you know what I'm saying, that they do actually experience as opposed to just being reactionary systems, is that what you were saying, that they're conscious?
Colors, the color red is a famous example of the quality, right? But the feelings of knowing, which don't have qualia, which don't have sensory qualia, are also very clear, and the next time you have a sonic experience, which I have at least once daily, I know that there's something there. I may know the rhythm of the missing word, those kinds of things, but there's a gap. William James, by the way, has the most magnificent description of the sympathetic experience, and I highly recommend it. The puzzling thing is that it's not sensory. It does not have qualia, and yet it is conscious content. And furthermore, philosophers who love abstractions are in that non-sensory conscious experience a lot of the time. Philosophers, mathematicians, everybody who thinks abstractly, they have that, they don't call it conscious, they should call it conscious, because it clearly has content, but it doesn't have immediately available content.
I have a super quick question again. What do you see being the final outcome of the brain mapping research that's going on? Obama delegated 10 billion to this study. That was a long time ago. I don't know how much more money's gone into this research now. What do you see being truly, without being science fiction oriented, realistically, what do you see being the ultimate outcome of brain mapping?
I don't think there is an ultimate outcome any more than there is an ultimate outcome of the invention of the telescope, for example. These things are open-ended, and all kinds of surprising things should occur, or there's probably something wrong with their instruments. Obviously, what's already happening with transcranial magnetic stimulation is that you can see clinics around the city that specialize in TMS, transcranial magnetic stimulation, for depression, but also for other conditions. And my personal guess is that people who are going to be elderly and having some of the negative symptoms of cognitive impairment, that they should march right away to the closest TMS clinic, which is free, I believe, in many cases, or covered by insurance in many cases, and try it out to see if their memory, short-term memory improves. The hippocampus, theta actually is closely associated with the hippocampus, and hippocampus is the first place where you stick memories of conscious experience. So yeah, I think that's actually a wonderful discovery, and it's based on endogenous theta that we know is associated with memory, and then people figured out that you can stimulate this darn thing. And you can do it from the outside, and it's safe and effective, and at least effective for moderate depression or serious depression. I think that's one of the directions that we're going to go. I don't think, my guess is that 10 years from now, we won't understand what age-related cognitive dysfunction is all about, because we'll have so many ways of addressing it. So I think that's clearly one of the ways we're going to go, naturally, because human beings always find out fiendish ways of applying science as well as beneficial ways. There will be, I don't know, Chinese agents around to use directed energy on our brains. That's not meant to be an insult to Chinese agents, who I'm sure are earning their the yuan as much as they can. So anyway,
Well, actually, Russia is believed is already doing that with the, it's a new form of warfare that was on 60 Minutes. I can't remember the name. Okay, anyways, the point is, it's believed Russia is already doing this.
I just
You could go
don't-
on 60 Minutes and watch it, but
yeah,
what
I
you're
just
saying has
noticed-
already happened.
I think any technologically advanced nation is already playing with it.
I couldn't think of the term, they're using microwaves to infiltrate a human brain from a distance. And it creates all kinds of cognitive complexities. It was on 60 Minutes, so it's actually happening. And it's believed it's Russia, which is no surprise.
I think we have a lot of questions. I just realized or some questions from the Zoom audience. One just came up in a chat.
Okay,
If anyone from the Zoom audience has a question, please I haven't seen any hands raised, but please just unmute yourself and ask the question. You can use the raise hand function, that would help. Arlene Kozakov has a question.
All right, no, my question is about dreams. Do dreams, can they give us real insight into ourselves? Do they have real meaning? And because some of the dreams are outlandish, others relate to our past lives.
yeah, I personally do not believe in the past life thing. But Jungian interpretation of dreams certainly has a version of that. It's not quite past lives, but it's the archetypes that are universal, that may show up in dreams. I'm a skeptic about archetypes, but certainly universal themes show up in dreams. I also think that one can use dreams in a sensible way. For example, to get insight into your own emotional states that may not be conscious during waking. And I've had all kinds of dreams that surprised me. Actually, one of the things that I think is so interesting about dreams is that in my experience, at least, dreams are by far the most creative state of the daily cycle. I'm not very creative when I'm awake, but my unconscious is dangerous, or at least creative.
Are there any other questions from the Zoom audience?
These, by the way, these are all questions that are often not sufficiently studied and which could be studied just about by anybody here with relatively basic equipment. So if anybody wants to start a consciousness lab, let me know.
Great speech. Thank you.
I think we're gonna have to
Thank
end
you.
it there.
Okay.
We're exhausted our speaker, I think. So. We'll have you back again for another.
I hope so. I would like that very much.
All right, thank you all.
There's a discount code.